everyone. Today we'll discuss what is the application of theory of computation. In the series of theory of computation lecture, we have discussed what is symbol, what is alphabet, what is string, what is language. And in the previous class we were discussing what is sigma power, everything we have discussed. And today we'll see what is the application of theory of computation. Okay, in C programming, okay, what are all these symbols are present. So this is the input. Okay, if you take C programming language, these are all the input symbols you are utilizing, right? You are using, right? So here when I say in C language, what is the strings? Okay, what is the strings? Strings are the programs. Okay, we write program like this, right? Void main, like that you are writing some code. This is what C programming. Okay, but in C we call it as usually we call it as program, but in TOC we call this program as a string. Okay, program as a string. So now what is C programming? So we all know, when will you say a code whichever you have written is a valid, okay, set of all valid code. Okay, so you will accept that code only when it is valid C programming. So what is C programming language means? Set of all valid programs. Here in the context of TOC, we define as set of all valid programs is called a C programming language. Okay, so which means how will you form a mathematical notation? Valid programs means I'm just having one set P1, P2, P3 up to it goes on, right? You cannot say the set is finite set. You can have any number of valid program in C, right? You cannot say, you cannot limit that, right? Only these many numbers of programs are possible in C. It is like an infinite set. You may have any number of programs, valid set of programs. Okay, so now you want to find how to find whether a given program is Pn is valid. Okay, this is what the second question. Okay, the first question, you know what is C programming? It is set of all valid programs. So we define it as P1, P2. When I see the set, it is an infinite set. Please note that this is the infinite set. Okay, infinite set. In this set, how to find whether a given program P1 is valid? Okay, how will you check it? Given a language L, whether a string is present in L or not. Okay, here in C we call it as a program, but in TOC that program is merely it is a string, right? So now string, whether this S is present in L or not, this is what the question. Okay, in TOC. But when I see the language L, this is the language C language. So C language L. So when I see the set L, it is the infinite set, right? L is the infinite set, and we only have the finite amount of memory in the computer. So this is the two problems. Okay, L is a infinite set, and infinite set computer has the finite amount of memory. So we cannot come up with the solution, right? So if it is a finite set, you can go through each and every member in the language, and you can say whether a given string is present or not. Okay, you can check and tell. But here the set is infinite set, but so you cannot verify each and every. It goes on, right? If you want to check whether the say S is present in L or not, in that case you will do like one by one you will do the comparison, right? But up to what member, in which number you will stop that comparison? No, you will not have an idea, because it is like infinite set, so it will be like looping. So this is not possible. So in that case, that L should be finite set, right? So we are just creating, if L creating a version. So if L is a finite, and this is the alphabet input alphabet A comma B, and L1 has the set of members. It is like set of strings with the length 2, set of all possible strings with the length 2. This is the L1 set denotes. So now you want to check whether A is present, A is present in L or not. So in such a situation, you can able to check it, right? Because here the L1 is a finite set, right? When you notice the L1, it is a finite set. So you just compare this A and AA, and you can tell whether S is present in L or not. Here you cannot, this is not matched, so this is not possible, and once it is not string S, so you'll be comparing with another element and another element. It goes on up to the final member. This is the final member here. This means it is a finite set. So you can able to say whether S is present in L or not. Okay, but in this case S is not present in L because only 4 members are there. 4 members are with the length 2, but the checking string is having 3, the length of 3, so it is not present in the L1. Okay, so in this situation you can say the answer. You can build the machine for this kind of problems. Here you just check L2 is equal to A, triple A, like that it goes on, right? So in that case, it is a infinite set, right? This is finite set, but here in this it is an infinite set. So you want to check whether yes, the string is present in L2 or not. But here when you see, this is when you are analyzing this set, the set consists of the members which string starts with A, right? Starts with A. So for this kind of thing, you have to come up with the finite representation. So finite representation is otherwise called as, we here simplest machine, finite automata. So you will have finite automata and you will be sending this language to the finite automata, and you will be checking whether this is present in this particular automata or not. When it is present, we will get the answer as yes. If it is not present, we will get the answer as no. Okay, so this is how we are going to build it. For this problem, you just to take this diagram. Okay, we have 3 states. Okay, we have 3 states. Here one will become a final state. So I'll explain you everything, what is state and everything in the next lecture. Here as of now, you just listen how this finite automata will look like for this problem. So L2 consists of the set, it is infinite set, consists of the strings with the starts with the symbol A. So you have to check this string whether this AB is present in this set or not. So for that we have built a finite automata. The finite automata looks like this. So here I am saying this is a starting state, and when I say double circled state, which means this is called final state, and this is called intermediate state. So I'm just naming, this is A, this is B, and this is C. Okay, so now when I give A, it goes to B, either A or B. I'm just making it as a looping. So here also when I say B, it goes to C. When I'm being in state C, whenever I'm getting A or B, I'm staying in state C. This is the finite automata. You just don't confuse now how to build this automata for this particular problem statement. No, that will be discussed in the next lecture. Now you just have, this is the finite automata. Okay, I'm just giving you, this is the finite automata. Now you want to check the string whether AB is present in this set or not. Okay, whether AB is present in this set or not. So now this is the string, right? So this is the string. So you are just giving the input string to here. So you have to start from the starting state. Here A is the starting state, B is the final state, C is the intermediate state. Okay, you can say it is intermediate state, but it is not a final state. Okay, so now S is a string AB. So now you are just giving this AB to the initial state, that is the starting state. Now you are in state A and you are looking the symbol A. Okay, when I'm seeing a symbol A, small a on the state capital A, I'm going to the state going to B, right? You are in state A. Upon seeing a symbol A, you are going to B, right? The next state is B. After that, you are having the symbol B. So you are just having the symbol B. Okay, you are in state B, and you upon seeing a symbol small b, it goes to same state, right? Self state, right? We are having one loop, right? So for the symbol B, and then you are having A. after the next to B we have small a. So you are in state B, and upon seeing small a, the moves remains on the same state. So again you are in state B. Again you are seeing the symbol small b, you are staying in small b, right? So now you just see whether the ended state is the final state or not. Yes, we have started from the starting state, and we have seen every input symbol and reached the final state. So which means that this symbol AB is present on the language L2. Okay, so this is what the problem, right? So I hope you understood something. So here we have, again we have infinite set. Okay, for this also you can able to form a finite automata. For this also you have to come up with the finite automata. So for this we have given automata, and we have checked whether this is present in a present in the set L2 or not. Okay, so now you have just to take the string BBA. Okay, BBA is the another string, so you want to check it. So just seeing the symbol B on the state A, it goes to C, right? It goes to C. You are in A. Upon seeing symbol small b, it goes to state C, right? So after A you are moving to C, and then you are having small b up by being in on state C. You are seeing the symbol B, small b, and you are the loop get remains, and your remains in C, right? And then you have small a. Again you are, when you are getting A on the state C, the state remains the same. So you have finished the scanning the symbol, but you are in the state, C is not a final state, right? You are in the intermediate state, so which means that you have not reached the final state. So this BBA is not present in set L2. Okay, this is how you check whether the string is present in L or not. Okay, so I hope you got some concept now. We'll be discussing the further details regarding the finite automata constructions. Everything will be discussed in the later lecture. Okay, so now we'll see. I'll revise one more time. So application of TOC is like, theory of computation is, just have in mind that whatever compiler we are using nowadays, that is the application of TOC. Okay, theory of computation. Okay, compiler is a software, right? It is checking whether a given set of code is valid or not, right? This is what the application of TOC. So now how people were come up with that solution through these concepts, right? This is what we have discussed here. So whenever you are seeing C programming, you will have the input as program, but when you have a TOC, that program is considered as a strings, right? That's it. Okay, so I hope you understood from this video something. Okay, we'll discuss later. Okay? Thank you.